Yep, you read that right. Global warming, popcorn, and tomatoes do have something in common, and I think it is pretty cool. Hi, and welcome back to the educational side of my channel. And today I'm going to explain some weird and awesome science. So let's get into it. When we think of global warming, what exactly comes to mind? Pollution, deforestation, increase in temperature, rise in sea levels, rise in CO2 levels. That's exactly what I wanted. Global warming is caused in part by the rising levels of CO2 in the atmosphere. But have you ever wondered why exactly is this? Why is carbon dioxide such a problem? Why not nitrogen or oxygen? The answer lies in quantum mechanics. There is a particular observation in science that can only be explained by quantum mechanics. An atom or a molecule can absorb a particular frequency of light. But why? Why does it only absorb these particular frequencies? Why doesn't it absorb it all? And what does it do with the energy? All atoms and molecules consist of electrons that are bound in certain orbits or definite energy levels. When such an electron receives an exact value of energy, it can get excited and jump into a different orbit, a higher one. This excited state, however, isn't permanent, and soon the electron releases the energy and comes back to its original orbit. But where does it get this exact value of energy from? Light. Composed of photons, light, or more technically, electromagnetic radiation, can exist with varying amounts of energy. When an atom or a molecule gets a photon of exactly the right energy, no more and no less, it can excite its electron to a higher orbit. And this is our linking point. This particular phenomena will come up in global warming, popcorn, and tomatoes too. So back to global warming now. Carbon dioxide, our main character here, works this way too and absorbs light with a particular energy level and releases it back in a random direction. When enough of that reflected light hits the earth, it causes global warming. But what is this major source of light for CO2 to absorb? Are you thinking of the sun? That's completely wrong. Carbon dioxide absorbs light from a completely different celestial object, the Earth. Didn't see that one coming, did you? When light from the sun hits the Earth, it gets reflected back out at a lower energy level, approximately in the infrared region of the spectrum, which is very close to the energy that an electron of carbon dioxide needs to get excited. Therefore, more the carbon dioxide, more the heat sent back into the Earth, and more the global warming. Ever wondered how popcorn actually expands to become what we eat? Have a look at this. Quite cool, isn't it? But what actually happened? When you put one of these kernels on a stove, it absorbs the heat and gets cooked. But what happens if I put this in an oven? Well, then, the story is quite different. To figure out what happens to popcorn kernels in an oven, we have to know how ovens work in the first place. The process is exactly the same as global warming, except here, the key molecule is water and not carbon dioxide. Water molecules too have a particular amount of energy that they absorb that exists in the microwave region of the electromagnetic spectrum, thus, the very common name microwave oven. So, when the water molecule absorbs a photon, its electron gets excited, and eventually the energy is distributed to the rest of the kernel, heating it up and cooking it from the inside. Eventually, all the popcorn gets cooked, and you can finally start watching that movie. Fun fact, this is literally how any food in an oven is cooked. This is also why plastic, ceramic, or glass bowls don't get as hot as the food we make because the molecules are much larger and the energy levels don't match up pretty well. I have to admit, this was more of a hook to pull you in to watch, if you're still watching. Tomatoes are one of the many fruits and vegetables that are grown in a greenhouse. Most of us know how greenhouses work by now, so I won't have to elaborate too much. But a lot of it is borrowed from what I said about global warming and the greenhouse effect. The glass covering the plants lets in visible light from the sun and blocks out the infrared radiation trying to escape the greenhouse, thereby maintaining a warmer temperature. The glass also helps create a more regulated and well maintained temperature and water level for optimum plant growth. In closing, I really hope you learned something new and interesting in this video. I know I watered down a lot of the fancy and sciencey stuff to help you understand, but if you want to learn more about it, you can always check out the links in the description. They were super helpful for my research for this video. If you want to see more of such videos, do support me by following the 3 golden rules of YouTube: liking, sharing, and subscribing. Not in that order, but all the 3 rules. If you have any suggestions for future videos, please drop them in the comments below. And as always, I'll see you soon.